So for today, what we're going to do is we're going to do our final day of word problems. We did cost and count, we did perimeter, we did area, and now we're looking at distance, right? So we're going to use our 5-step problem-solving system. The first step is to read the problem and understand it. Second is to define some variables. Third, set up some equations. Fourth, we're going to solve the problem. And then finally, we're going to answer the question. So let's look at the first step. We're going to read the problem. It says a barge travels 25 miles upstream in 10 hours. So they're going up against the current. Okay? It travels 50 miles downstream in 5 hours. The speed of the current remains the same during the travel upstream and downstream. Find the average speed of the barge in still water and find the speed of the current. Okay? Now, before we do the main problem, we do need to do a little bit previous to what we're doing. So first of all, I'm going to look at upstream. And I'm going to look at downstream. And I need to go D equals RT. And I'm going to start with those equations first. This is like part one. There's 2 parts to these types of problems. Okay? When I do this, D stands for what? Distance. R stands for rate. Yep. And T stands for time. And where do you see this? A lot of. What class do you see that a lot? Science. Yep. So you're going to notice that we're going to do some of the science stuff today. And I heard the other day you were doing a lot of math stuff in science, right?
Yeah.
Yeah, that's awesome. It's really good. You were doing slope. I heard you science the other day. Good. All right. Now let's pick apart our problem just a bit. First of all, it says a barge travels 25 miles upstream in 10 hours. Right? So I'm going to go to upstream, and what do I put in for what?
25 for the T.
Okay, 25 is my D, because it says distance, miles. Where does the 10 go?
And the time.
In the time. So, looks like that, doesn't it? All right, and then how do I solve for R? Yeah.
Multiply 10 by R and times
Okay, so I can go ahead and go 10R, and then I divide by 10, yeah? So the rate is 2.5. And I'm going to leave it just like that, because I'm not done with the problem. I'm just using this piece. Questions on this? Okay, then I'm going to come back up and I'm going to look at downstream. It says it travels 50 miles downstream in 5 hours. So what do I put in for D? 50 equals what?
R.
Yes, R parentheses 5. And then, like we mentioned before, I can multiply it. So I get 5R, and then I by 5. So R equals 10. Okay? So this is part 1. And it makes sense, because if I'm going downstream, my rate should be more than going upstream, right? Because what happens when I'm going downstream? What's the current? Yes, the current is going with me, so it's pushing me faster, right? All right, so that's part 1. Now we're going to go to part 2, and I'm going to do upstream. Oh, before I do upstream, sorry, I blew up. I need to define my variables. So I'm going to go X equals. Now, let's look at what I'm trying to find in the problem. It says, find the average speed of the barge in still water and the speed of the current. So X is going to be average barge. And y is going to be the speed of the current. Where did I find that at? Yeah, at the end of the problem. Notice it says, find the average speed of the barge in still water and find the speed of the current. Okay? All right, so now I'm going to do my upstream, downstream. Okay, so if I'm going upstream, here's the speed of the barge, and what does the speed of the current do to my vessel? It's going to push against it, right? So I'm going to go minus y equals 2.5. And I get the 2.5 from up above. Okay? If I didn't find out part 1, I couldn't do the problem. Right, so now I'm going downstream. So x plus y, because it's pushing my boat, equals 10. That's part 2. Okay, so I defined my variables. I should say I read my problem, I defined my variables, I came up with my equation. Now what am I going to do? I'm going to solve to find out what my answers are. So x minus y equals 2.5. X plus y gives me 10. I'm going to what? Subtract. Or, you know what? How about add? Dun, 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 dun. I think it's easier, okay? So 2x equals 12.5. Because I eliminated y by adding. I mean, you could subtract, it'd be fine. Divide by 2, x gives me what? 6.25. What did I just find? Okay, so what would be the label? Yes, miles per hour, and in parentheses, speed of barge. Okay, so you got to make sure that you put the label and you tell me what you just found. Like, what does that mean? Good. I'm glad you get it. That's good. All right, now what I'm going to do is I'm going to grab another equation. So I'm going to go x plus y equals 10. Okay, I'm going to put in 6.25 because that's what I found. I'm going to subtract my 6.25. Y gives me, excellent, 3.75 what? Miles per hour, and it is the, yes, speed of current. Do you guys understand what the current is, what that is? Mm-hmm. Okay, it's how fast your water's traveling.
Which way?
Yeah, and sometimes it can look like there's not a lot of current, but there is. Sometimes there's currents underneath the water, like our Mississippi River. They can pull you under. You have to be careful, right? Yeah. All right, now go back and read the question. Did I answer it? Yes, I found out the speed of the barge, and I found the speed of the current. Okay? Why would that be helpful in everyday life? Like, who cares? How fast your barge needs to go, how much the current is. It can do wear and tear on your barge. How much should your cargo be? What if you need to meet a timeline, right? So how fast can I go? When will I get there? When do they need the cargo, right? Yeah, so all of that they take into account when they're moving barges up and down our Mississippi River, right? All right.